Hi team. So today I'm going to very basic data engineering things. So we are talking about the Spark, right? So Apache Spark is unified compute engine designed for parallel data processing. So this is the how Spark, and it's unified compute engine, and this is open source tool for big data analytics as well as data processing. The key feature is flexibility, scalability, and task variety, right? So when we talk of flexibility means support multiple programming language like Python, Scala, Java. When we say scalability means if an efficient system ranging from laptop to large cluster, we can increase the cluster. That means scalability. Task variety, SQL processing, machine learning, and streaming analysis. Advantage, open source and widely adopted industry, and fast efficient data processing, handle large scale data sets. So this is how we talk. Now when we talk about unified, that means it's a consistent API drivers like data loading, SQL query, machine learning, and streaming. These are unified platform that and Element needs to stick together multiple tools, offer end-to-end solution for data warehouse, data workflow, and something, right? So Spark provide efficient data loading, SQL query, machine learning, and efficient. So this is how the Spark do. Okay, and advantage of Spark, if the we perform SQL query, then we apply machine learning model. The Spark optimizes entire process into single data scan. So this is one scan. We can do multiple things, right? This is save the time and the resources, which ultimately it's the money. Compute engine. So core focus is dedicated for computation, not data storage. This is only for core focus on the data computation. Optimized process data where it's reside. So wherever data is reside, we go and do that processing. Data storage compatibility. It's cloud compatible. Cloud storage Azure, Amazon S3. Distributed file system is HDFS. Key value is Apache Cassandra. Message based Apache Kafka. Advantage, flexibility and cost efficient. Flexibility means work with the diverse storage system. Cost efficiency means avoid expensive data movement. And component Spark decouple storage and computation. More adaptable Hadoop integrated storage computation. So this is what we talk. Why this is important? Data expensive to move. The Spark focus on computation over the storage system, ensure flexibility and cost. Library, it supports Spark SQL, it supports lib, it supports Spark streaming, it supports graphs. Okay, so these are the four things this supports, so which I am going to headline here, right? Beyond the standard library, 100 of external library are available ranging from storage connector to advanced machine learning algorithm. Example is here. So this is the link I have given. You can use, guys. Spark psychology, unified API optimization, and construct with Hadoop. Hadoop is highly coupled storage, while the computational map reduce might be flexible. Spark decouple computation from storage and making it easier to integrate with diverse storage system suitable for environment cloud computing. Right? Scalability, speed, flexibility ecosystem. How to get started with Apache Spark. This is how to get started. Install Spark in local machine or cluster. Spark API preferred. So this is how that did. Now when I talk about the shift of the shift of hardware trends pre 2005, processor the speed improved every year, and the application become a faster without needing any code changes. The single thread program automatically benefits from the increasing the CPU, not the number of nodes. It's increasing the CPU speed. Post 2005, hardware manufacturer hit the wall and heat distribution limit. So how much hardware limit you can do? Let's say you have a small computer and you want to increase. It will become a very big size. To solve this problem, they maintain process developers shifted from multi-core CPU to winning. Application now required parallelism to achieve the performance improvement. Old single-thread system become obsolete. expansion of data storage and collection while processor speed growth. So data storage and collection technology continue to advantage storage. The cost of storing 1 TB data halves every 14 months, making feasible organization to store massive data sets. Data collection, camera, sensor, public database become a cheaper. Example, camera 12 megapixel webcam now cost $3 to $4. Sensor is used for industrial system, telescope, and gene sequencing machine. Problem with the traditional system: traditional software programming model built for single thread, small scale data cannot be handled. Massive data sets, large scale data sets, Apache Spark, again, the same things. Parallel scalability, unified framework, organization modern data. The new era of data, data abundant, data is too much. Parallel, we need to do parallel. Traditional, some difficulties, which we talk. The birth of Spark 2009. Spark was born. Research at UC Berkeley AMPLab led by Matai Zaharia and others. 2010 first paper Spark cluster computer with the working sets was published. And the key issue with Hadoop MapReduce Spark: inefficient multi-pass workflow, machine learning required iteration, and the Hadoop was not able to work. API limitation, MapReduce programming model was rigid for workforce, making the default build complex application. How Spark differ: Spark functional programming language for concise expression, multiple steps, implement in-memory engine for faster data. Yeah, so first one is functional programming make very simple. Early milestone batch processing first version. Then attractive use, this Spark 2011 build a Spark supports SQL query. In 2011 growth of thread, recognized need to versatile AMPLab team developed a standard library, AMLib, Spark streaming, graphics, and so on. Becoming Apache 2013, the Apache Foundation and Databricks started from AMPLab. Major released Spark 1.0 and then Spark 2.0, and after 2.0 now Spark 3.0 also present. But I haven't added key innovation: Spark compatible with API, in-memory processor, structure streaming, current status, and so on. Right. So you need to read everything's Spark critical today, and this is how continuous expansion is going, integration with AI, cloud natives, why we learn Spark, running Spark application. I assume download this application, but you should try for 3.0. And yeah, this is how which we study. So I have given guys very high level. I can't say I have gone through all the topic, but you guys can work and learn.